Hello student, this is a continuation of our previous video which was based on the electricity chapter of class 10th student. So in that video we studied about the electric current, electric potential and potential difference, electric circuit and diagram. So if you didn't see that, please check that video. So in this video we are going to cover Ohm's law, resistance of a system of resistor, heating effect of electrical current and electric power. So first we will start with Ohm's law. Ohm's law states that at constant temperature, voltage, or you can say potential difference, of the terminal is directly proportional to current present in the conductor. So here we can write it down. Voltage is proportional to the current. So symbolically we can write it as V is proportional to I. So it means that when the voltage increases, then current has to increase. So if in a circuit, if we assume this is a circuit here, if this voltage will increase, so the current which is passing through this circuit will also increase. So that's the meaning of directly proportional. So when we remove this proportionality and put equal to sign, then we have to place a constant. So here the constant is R, which is called as resistance. And it is constant of proportionality. So what is resistance? It is a disturbance in the flow of current. So the question comes how this disturbance is formed. So let's take an example. Here is a voltage V. This is positive and negative terminal. So we have studied in part 1 that when we have a conductor and it is connected to a battery, then current will flow from positive to negative terminal and electron will move from negative to positive terminal. So all the electrons you see, they are moving from negative to positive terminal. But here what happens when the electrons are moving, they collide with other electrons. If here is a one electron and these are other electrons. So what happens? This electron, when it moves, it will collide with other electrons. So due to that, its motion will disturb. Suppose if this electron has to move from this point to this point. So what happened? There will be infinite collisions takes place, and due to that the motion of the electron will slow down. So this is called as disturbance. So this disturbance is less in the conductor but it is very high in the insulators. So that's why when we have to flow the current from one end to another end, so we are not using the insulators because insulators has high resistance which will disturb the flow of current. I hope you understood this part properly. Now V is equal to IR. So R is equal to V by I. So by this formula we can find the resistance. So if we draw the graph of voltage and current, this straight line is the resistance, and here is the current in the x-axis and the voltage in the y-axis. So if we try to understand it more properly, so we can plot. So here we plotted the point A, B, C, D, E. So at A, current is 1 ampere and the voltage is 1 volt. At B, current is 2 ampere and the voltage is 2 volt. Similarly, E has 5 volt and current is 5 ampere. So if we have to find the resistance, we can write it as R is equal to V by I. So at A, V is equal to 1 volt and I is equal to 1 ampere. So R will come as 1 by 1. So 1 ohm. Ohm is the SI unit of resistance and this symbol is called as omega. So at B, V is equal to 2 volt and the ampere is 2. So again, resistance we are getting it as 1 ohm. Similarly, at C, V is 3 volt and the current is 3 ampere. So R is equal to 1 ohm. So as you see, everywhere resistance is same. So it means that resistance is constant but voltage and current is changing. And how it is changing? Current is increasing and voltage is also increasing, but resistance is constant. So this is the Ohm's law. So we can note it down. SI unit of resistance is ohm. Symbolically it is represented as omega. So how we can define 1 ohm? 1 ohm is defined as when 1 volt of voltage is supplied and 1 ampere of current is formed, then it is said to be 1 ohm resistance. Let's assume if we are using a rheostat, then what will happen? We know that rheostat is a variable resistance. It means that the resistance value is not fixed, means it varies. So if here we take a example, here we are using a rheostat. If we need a constant voltage, if the voltage is constant and here resistance is variable, so what will happen? Current is inversely proportional to the resistance. How this relation we got? We know that V is equal to IR. So I is equal to V by R. And here V is a constant. So I is inversely proportional to the resistance. This is the first condition. Suppose if we want same current, then if the current is same or constant, then in this case V is directly proportional to the R. It means that if we increase the resistance, then we have to increase the voltage. So Ohm's law, in short, we can say that it's a relation between voltage, resistance and the current. So we can note it down. Now we will study about the factors affecting the resistance. First factor is length of the wire. So here resistance is directly proportional to the length of the wire. So how it is directly proportional? Let's take an example. In this figure, you see we are taking two cases where the case 1 has length of the conductor L, and in the second case the conductor has the length 2L, means it's the double of the first conductor. And here the conductor which one we are taking has same property as the second conductor, means both conductor has same property. So here if the length is L and length is 2L, so what happened, more number of electron is present in the 2L length, means this is double. So what happened in this part, more electrons will present. So more number of electrons means more collision. More collision means more disturbance. More disturbance represents higher resistance. So here when the length of the wire increases, it means that its resistance will also increase. So that's why if we use a very long wire, so we have to think that it has a higher resistance. So current will not flow very fast. There should be some disturbance due to high resistance. So here we can write it, R is directly proportional to L. We can keep it as a first relation. In the second one, cross-sectional area of the wire. So here resistance is inversely proportional to the cross-sectional area. Let's understand this by using a figure. Here in this figure, we are using same length wire, but the area of the wire is now 2A. Initially it was A, now it becomes 2A. It means that here the electron can flow easily because the cross-sectional area becomes, so higher the cross-sectional area, lesser the number of collisions, so disturbance will decrease. So here resistance will also decrease. So that's why resistance is inversely proportional to the area. This we can consider second relation. So from first and second relation, R is proportional to L by A. And when we remove this proportionality, we have to put a constant, which is represented as rho. So rho is constant of proportionality, and it is also called as resistivity. Resistivity is a characteristics of a material. What is the meaning of characteristics of a material? It means that resistivity only depends upon the nature of the material and the temperature of the material. It doesn't depend upon length and area of the same material. It means that if you are using same material, here we are using a copper material, both are copper, but length is different. This is supposed to L and this is L. The material is same. So the resistivity will be the same. Here, if you are using different material of same length, so because resistivity only depends upon the nature of material, so in this case both has different resistivity. Suppose this is rho 1 and here it is rho 2. So rho 1 is not equal to rho 2. So resistivity depends upon two factors. One is the nature of material, and the second is the temperature. So at 20 degrees Celsius, resistivity value will be different, and at 30 degrees Celsius, resistivity value will be different. So we know that resistance depends upon the resistivity, And resistivity depends upon the nature of the material and the temperature of the material. So these two are also applied as the factor of the resistance. I hope you understood this part properly. If you have any doubt, you can comment me in the comment box. I will try to resolve your doubt. Now we will solve few questions based on the formula R is equal to rho L by A. Let's try this question. In this question, resistance of a wire is given as 1.2 meter and the diameter is 0.4 mm. The resistance is 2.5 ohm. Find the resistivity of the material. So according to the question, given values are length 1.2 meter, diameter 0.4 mm. We can write it as 4 into 10 to the power minus 4 meter. So radius will become 2 into 10 to the power minus 4 meter. And resistance is given as 2.5 ohms. So if we use the resistance formula, so in this formula, resistance is given, length is given, area we have to find. How we can find the area? Diameter is given, so we use the formula pi r square. So the question comes, why we use pi r square? As you see in this figure, this is our cross-sectional area and this area is in the circular form. So that's why area of circle we will use for finding area of cross section. So area is equal to pi r square equal to 3.14 into 2 into 10 to the power minus 4 whole square. So 12.56 into 10 to the power minus 8 meter square. So if you substitute the values in the resistance formula, resistivity is equal to R into A by L. R is 2.5, area 12.56 into 10 to the power minus 8, length is 1.2 meter. So resistivity will come as 26.16 into 10 to the power minus 8 ohm meter. This is the answer. So let's try one more question. Here in this question, a wire of resistance 2 ohm is stretched to double its length such that its volume remains constant. What is the resistance of the stretched wire? If we see this question with a figure, as you see we have two figures, figure 1 and figure 2. In figure 1, length of the wire is L and area is A. In the figure 2, length of the wire is 2L, which is given in the question, double of its length. But area will become half. Why the area will become half? According to the question, both the wire has same volume. So V1 is equal to V2 and volume is area into length. So A1 into L1 is equal to A2 into L2. So if we substitute the value A1 as A, L1 as L, A2 we have to find it and L2 is equal to 2L. So A2 will come as A by 2. We have to always remember this concept. When the length will become double or triple, area will become half or 1/3 and it is vice versa. So if area becomes double, then length will become half. Many times students get confused. They only think about the length but area will also change. So now if we use the resistance formula for figure 1, R1 is equal to rho L1 by A1. For figure 2, R2 is equal to rho L2 by A2. So R1 by R2 is equal to rho L1 by A1 divided by rho L2 by A2. So because material is same, so resistivity will also be same. So resistivity gets cancelled. So L1 by L2 into A2 by A1. R1 by R2 will be equal to L by 2L into A by 2 into A. So after solving, we will get 1 by 4. R1 is 2 ohm given. R2 we have to find. So R2 will come as 8 ohm. This is the answer. After that, you will practice few of the questions based on the same topic for better understanding and comment your answer in the comment box. Now we will study about the resistance of a system of resistor. Here we will know how two or more than two resistors are connected into the electric circuit. So there are different types of resistor arrangement. First is the series arrangement, then parallel arrangement, and then combination of both series and parallel arrangement. So first we start with series arrangement. In series arrangement, the circuit has only one path through which the current can flow. Suppose we have three resistors. Here we can represent it as R1, R2 and R3. So if we connect these three resistors in a series circuit, so the circuit will be formed. As you see in this figure, current is moving from positive terminal to negative terminal in this way. So when the circuit is in the series form, it means that in a single wire, all the three resistors are connected with it. In other way, if we understand this, suppose this voltage will supply the current of I, and we make this point as A, and here it is a point B. So when the current start moving from A, the current will move in a single wire. Means from A to B, it will follow a single path. And all the resistor will get the same current. So here 2 points are clear. One is in series arrangement, all the resistors are connected into a single wire. And second is the current which is received by each of the resistor whose magnitude is same. Its current remains the same. So we can note down these 2 points. So here we noted down in series arrangement, the current remains the same throughout the resistor. Now we will see what change will happen in the voltage. So here our battery produces voltage V. So if we consider first resistance R1 and we use the Ohm's law, so we know that V is equal to IR. And here in series, current remains the same. So for the first resistor, we know that current is same and resistance is R1. So when you will multiply, we will get the voltage V1. So this voltage V1 is different from the total voltage. So it means that each of the resistor has its own voltage. For resistor R1, it is V1. For resistor R2, V2. And resistor R3, it is V3. So this point we can also note it down. So here we noted down each resistor has different voltage. Now we will see how the potential difference will change for each of the resistor. So here you see the figure. Total voltage supplied is V, and the resistor R1 will take the voltage V1, R2 will take the voltage V2, and R3 will take the voltage V3. So total voltage, which is V, is equal to the sum of individual voltage. So from here we can say that if we add all the potential difference of the resistor, that must be the equal to the potential difference of the battery. So we noted down the total potential drop is equal to the sum of individual voltage drop across these resistors. V is equal to V1 plus V2 plus V3. Now we will find total resistance of the electric circuit. We know that V is equal to V1 plus V2 plus V3. By applying Ohm's law, V is equal to IR. So if you substitute V is equal to IR in place of V, V1, V2 and V3, so we can write it as IR, and here the R is the total resistance or equivalent resistance, is equal to IR1 plus IR2 plus IR3. We can take current common, II cancel, so total equivalent resistance is equal to the sum of individual resistance. So this is the formula to find the total resistance in series. Now we will see one question based on this logic. As you see in this question, a battery of 6 volt is connected in series with 3 different resistors of 12 ohm, 6 ohm, 4 ohm as shown in the figure. Current is same in each resistor. We have to find the total resistance and calculate the potential difference across each resistor. So according to the question, voltage is given as 6 volt, which is the total voltage. R1 we can consider as 12 ohm, R2 6 ohm, R3 4 ohm, and here current is same. So we already know that in series current remains the same. So each of the resistor will get the same current. So in first part we have to find the total resistance. So R equivalent is equal to R1 plus R2 plus R3, and here R1 is 12 ohm, 6 ohm and 4 ohm. 22 ohm is the total resistance. In the second part, we need to find the potential of each resistor. So for doing it, we need to first find the value of the current. Why we have to find the value of current first? Because here for the 12 ohm resistor, V1 is not known and current is also not known. So we can't use the Ohm's law. So that's why first we find the current and then we apply the Ohm's law. So we know that V is the total voltage. It is equal to I into total resistance. So voltage is 6 volt, current we don't know, and equivalent resistance is 22. So I is equal to 6 by 22, so 3 by 11 ampere. So current is same for all the resistor. If we have to find the V1, V1 is equal to IR1 and I is 3 by 11, R is 12, 46 by 11 volt. Similarly, V2 is equal to IR2, 3 by 11 into 6 is equal to 18 by 11 volt. V3, IR3, 3 by 11 into 4, 12 by 11. So if you add total voltage, you will get the 6 volt. So now we will see the second type of arrangement, which is parallel arrangement. In parallel arrangement, when two or more resistors are connected between the same 2 points, then they are said to be connected in parallel combination. As you see, this is the circuit diagram of a parallel arrangement. Here we have three resistors R1, R2 and R3. R1 is connected to a point A and point B. R2 is also connected to the point A and B. R3 is also connected to the point A and B. So here we can say that all the resistors R1, R2 and R3 are connected to the same 2 points. So it means that this arrangement is said to be parallel arrangement. So in parallel arrangement, if the voltage is V and here is the current moving with I, so when the current will reach at point A, so this current has to flow in three paths. One is with respect to R1, we can name it as I1, R2, I2, and with respect to R3, I3. So each of the resistor is getting different current. But in parallel arrangement, voltage remains the same. So voltage of R1 is equal to the voltage of R2, it is equal to the voltage of R3. So it is reverse of the series arrangement. In series arrangement, current was same but voltage varies. But in parallel arrangement, current varies and voltage remains the same. So we can note down these 2 points. So here we noted down in parallel arrangement, voltage remains the same throughout the resistor and each resistor has different current. Now we will derive the formula of the total resistance of the parallel resistors. So we know that total current is equal to the sum of individual current across the resistor. We discussed this previously in this figure. If this is the current I, so it is equal to the sum of individual current I1 plus I2 plus I3. Means I is equal to I1 plus I2 plus I3. Same thing here noted down. I is equal to I1 plus I2 plus I3. By applying Ohm's law, we know that V is equal to IR. So I is equal to V by R. So if you substitute the current value in this relation, so we will get it as V by total resistance or equivalent resistance is equal to V by R1 plus V by R2 plus V by R3. So if we take voltage common, because voltage is same for each resistor, so 1 by R, which is equivalent resistance, equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the total equivalent resistance formula for the parallel arrangement. So let's try one question based on this concept. In this question, we have to calculate the equivalent resistance in the following circuit and also find the current I, I1 and I2 in the given circuit. Means total resistance we have to find and then the current values we have to find. So according to the question, R1 is equal to 4 ohm, R2 is equal to 6 ohm and total voltage is 24 volt. For finding equivalent resistance, we use the formula 1 by R. is equal to 1 by R1 plus 1 by R2. 1 by R is equal to 1 by 4 plus 1 by 6. 1 by R is equal to 5 by 12. So 5 by 12 is the value of 1 by R. So R is equal to 12 by 5. Sometimes a student do mistake. So whenever you get the value of 1 by R, you have to take the reciprocal of it. So this is the answer for the first part. In the second part, we need to find the current. So total resistance we got, total voltage we have. So by using Ohm's law, I value we can find by applying Ohm's law. V is equal to IR. V is 24. Current we have to find and total resistance is 12 by 5. So I is equal to 24 into 5 by 12. So 10 ampere. So 10 ampere is the total current. Similarly, we can find for the I1. We know that in parallel arrangement, V is same, voltage is same. So V1 is equal to V. So by applying Ohm's law, V is equal to I1 into R1. V is 24, I1, R1 is 4 ohm. So I1 is equal to 6 ampere. Now we can find I2. So V is equal to I2 into R2. 24 is equal to I2 into 6 ohm. I2 is equal to 4 ampere. So if you add I1 plus I2, you will find that I is equal to I1 plus I2. This is 6 ampere, 4 ampere, which is equal to 10 ampere. So from that you can check your answer whether it is correct or wrong. This is a conceptual question. The motive to solve this question is to explain one concept, which I will explain you after solving this question. So here, three resistors of 1 ohm, 2 ohm and 3 ohm are connected in series and parallel separately. What resistance will the two combinations offer? If we draw the two separate diagram, one for series and one for parallel, as you see, here we have a two different circuit, one for series and one for parallel. Both the circuit has same resistance 1 ohm, 2 ohm and 3 ohm. So if we use the total resistance formula for series, so R is equal to R1 plus R2 plus R3. So 1 ohm plus 2 ohm plus 3 ohm. Total resistance will come as 6 ohm. If we use parallel formula for finding the total resistance, 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by 1 plus 1 by 2 plus 1 by 3. So 1 by R is equal to 6 plus 3 plus 2. So 1 by R 11 by 6 ohm. R is equal to 6 by 11 ohm, which is approximately equal to 0.55 ohm. So you see here we are using same resistor, only the difference is arrangement. when these three resistors are connected in series, we are getting 6 ohm, and when it is connected in the parallel, we are getting 0.55 ohm. So it means that in series arrangement, resistance is very high, and in the parallel, resistance is low. So what impact it will create in the circuit? As we know, current is inversely proportional to the resistance from the Ohm's law. We know that V is equal to IR. So current is inversely proportional to the resistance. If this R value will increase, then current has to decrease. So from here, we can say that if we are connecting 10 bulbs in series, so it means that resistance will increase. So the current flow will decrease. But when we are connecting that 10 bulb in parallel, so resistance will be minimum, current flow will be more than the series arrangement. I hope you understood this part completely. So we can note down that point. So this is one of the point which explains that why we need to use parallel arrangement over the series arrangement. So in parallel arrangement, resistance is low, so current flow is high. But in series arrangement, resistance is high, so current flow is low. This is the one of the point. So I will explain you the second advantage of the parallel arrangement over the series arrangement. Suppose if there is short circuit happens at this point. So what change we will notice? Initially current was moving in this direction. Now if short circuit happens, then current will not move. So there is no current flow in any of the resistor which is present into the electric circuit. If we do the same thing with the parallel arrangement, in parallel this is the current, and here it splits into the three parts. So if any of the parallel arrangement have short circuit, let's assume this one. So then what we will notice? Only I1 will not flow, rest all current will flow. So it means that only the influence due to this short circuit is influenced by 1 ohm resistor. 2 ohm and 3 ohm will not get affected. So if we have to identify which resistor is not working or which resistor is defective, we can easily identify. But in series arrangement, it's very difficult to identify. We have to check each and every of it and then we can resolve it. So that's why in a festival, we are using a series bulb for decorative purpose. So in this series bulb, if any of the bulb will get fused, so no flow of current will be present in that series bulb. But when we are using a parallel arrangement of the bulb, so if any bulb will fuse, that will only gets affected, rest all will work properly. I hope you understood this part completely. One more advantage we will discuss with respect to the voltage. So in series, voltage varies. Each resistor has different voltage, but in parallel, each resistor has same voltage. So if we are supplying 220 volt of current of voltage, so here in series, each of the resistor will get different voltage. So it will influence the flow of current. But in parallel, all the resistor will get the same voltage. So this is one of the advantage over the series. Now we will discuss about the voltmeter and ammeter arrangement in electric circuit. First we will see ammeter arrangement. So here two figures are given. If we consider this as figure 1 and figure 2. Both the figure has same resistance R and same voltage V. Only the difference is in the first figure, ammeter is connected to the series, and in the second figure, ammeter is connected to the parallel. If the current moves in this direction, so current will pass through the ammeter, and ammeter has low resistance. So due to the low resistance of the ammeter, the current will easily pass through it without any disturbance. If the ammeter has high resistance, so ammeter will disturb the flow of current. So due to that, the reading of the ammeter will not be accurate. So that's why we consider ammeter has low resistance. So here current is moving only one direction and ammeter is present in series. So current will pass through the ammeter. But if I consider same situation in the second figure, here is the current I, name this point as A and B. So at A, if I zoom it, this current will split into two parts, I1 and I2. So ammeter will take the reading of I2. But here we have to find the current between A and B. So at A, current is I. And at B, again the current will be I. Why it is I? Because see, from A to B, if we see the ammeter, here the current is I2. And from the resistor side, here the current is I1. So again, both the current will join together and it will form I. So at A and at B, the magnitude of current is I. But the problem is ammeter is taking the reading of I2 and we need the reading of I. So it means that ammeter is taking the wrong reading. So that's why ammeter we are not connecting into the parallel. Ammeter is always connected into the series. So this arrangement is wrong. Second point, we can also say if you compare I1 and I2, I2 magnitude is more than the I1. As the ammeter has low resistance, so most of the current will pass through the ammeter. So here ammeter might get damaged. So this is also the second reason why we are not using ammeter in parallel arrangement. So we can note it down. So here it is mentioned that ammeter has low resistance. So it is necessary to connect an ammeter in series with a resistor to measure the current through it. Connecting the ammeter in parallel would result in the current flowing through the ammeter instead of the resistor, potentially causing damage to the ammeter and not providing an accurate measurement. Now we will study about the arrangement of the voltmeter. So as you see, we have two figures. In figure 1, we connect the voltmeter to the series arrangement and here voltmeter is connected to the parallel. So when the current will move from the voltage, it is I, here also I. This voltmeter has high resistance. Because of high resistance, voltmeter will disturb the flow of current. So when the current move from, assume this point as A and this point as B, so current will vary. This current could be I1. So we will not able to get the voltage reading properly. In parallel, if we see this is the current I, here is current I, this is point A, this is point B. If we zoom it, current will split into two parts, I1 and I2. This I2 will face high resistance due to the voltage. So there will be no flow of I2 through the voltmeter. So here I1 is actually I. Now the voltmeter will take the accurate reading of the voltage between the point A and B when it is connected in the parallel. But when it is connected in the series, it will disturb the flow of current. Means here might be possible that no current will flow, means it approximately 0. So we can write the statement voltmeter has very high resistance to measure that its connection does not alter flow of current in the circuit. Now, if it is connected in series, then no current will be there in the circuit due to its high resistance. Hence, it is connected in parallel to the load across which potential difference to be measured. We already studied that voltmeter is used to measure the voltage and ammeter is used to measure the current. Now we will study third type of arrangement, which is combination of series and parallel arrangement. In both series and parallel arrangement, in a circuit, series and parallel, both types of arrangements are combined together or present together. As you see, we have two figure 1 and figure 2. In figure 1, if we consider this as R1, R2 and R3. So R2 and R3 are parallel and R1 is in series. Similarly, in the second figure, R2, R3 are in series and R1 is in parallel. So this type of circuit, we have to first identify from where we have to start the finding the resistance. So in the first figure, we will first find the resistance of parallel and then we will find the resistance of the series. Similarly, in the second figure, we first find the resistance of the series and then the resistance of a parallel. So if we take R1 is 1 ohm, R2 is 1 ohm, R3 is 1 ohm. First we have to find the equivalent resistance of R2 and R3. Write it as 1 by R is equal to 1 by R2 plus 1 by R3. 1 by 1 plus 1 by 1, 2 ohm. So 1 by R is equal to, or R dash we can make. So R dash is equal to 1 by 2 ohm. So now total equivalent of R2 and R3 is 1 by 2 ohm. So if we think what type of figure now it will become, so this is the new figure. Here R1 is 1 ohm and R dash is 1 by 2 ohm. And now we can find the total resistance. 1 plus 1 by 2, 3 by 2 ohm. This is the answer for this figure. Similarly, if we try second figure, so first we have to find the resistance of R2 and R3. So it is already in the series. So new resistance R dash is equal to R2 plus R3. We keep the same value 1 ohm. So new resistance is 1 plus 1, 2 ohm. So new circuit diagram will be like this way. So now R dash is parallel to the R1. So total resistance will be 1 by R is equal to 1 by R1 plus 1 by R dash. 1 by 1 plus 1 by 2. So 1 by R is equal to 3 by 2. R is equal to 2 by 3 ohm. So this is the total resistance for two different circuit. Here I explain you one trick. This trick is used for the series and parallel combination. Here I am explaining you one trick. If we have three resistor, these are the three resistor R1, R2 and R3. And we have to form a circuit with the help of these three resistors. So there will be total 4 arrangements will be formed, not more than that. So first arrangement could be when all are in the series. These are all in series. Second arrangement could be all are in parallel. In the second figure, all the resistors are in parallel. In the third figure, 2 are in parallel and 1 is in series. In the fourth figure, 2 are in series and 1 is in parallel. So there are total 4 figure could be possible when we are using the 3 register. In exam, this type of question comes where the 3 registers are mentioned we have to find the total resistance. And one point always remember, series resistors has maximum resistance. This one has maximum resistance and parallel one has minimum resistance. As you see in this question, you are given three resistors of 1 ohm, 2 ohm and 3 ohm. So by diagrams, how will you get a resistance of 6 ohm, 6 by 11 ohm and 1.5 ohm? So as I explained you previously, here we have a three resistors. It means that we have to draw four figures and check each of the resistance of it. So first we will take the series arrangement. Resistance are noted down 1 ohm, 2 ohm and 3 ohm. So total resistance is 1 ohm plus 2 ohm plus 3 ohm. So total resistance is 6 ohm. Our first condition is fulfilled. Circuit forms the 6 ohm resistor. We are getting 6 ohm. It means that it is first one is the series arrangement. Let's see the second one. In the second arrangement, we took a parallel arrangement. So here the total resistance will be 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by R is equal to 1 by 1 plus 1 by 2 plus 1 by 3. 6 plus 3 plus 2, 11 by 6 ohm. So R is equal to 6 by 11 ohm. So this is the answer for our second condition, where we have to prove 6 by 11 ohm total resistance. So then it is a parallel arrangement. Third one is 1.5 ohm. So as I explained you previously, if we have this type of arrangement, first we do the parallel arrangement. So 1 by R dash is equal to 1 by R2 plus 1 by R3. So 1 by R dash is equal to 1 by 2 plus 1 by 3. 5 by 6 ohm. So R dash is equal to 6 by 5 ohm. After finding the parallel arrangement, now we will do the series arrangement. So R is equal to R1 plus R dash 1 ohm plus 6 by 5 ohm. So it is equal to 11 by 5 ohm. So we get approximately 2.2 ohm. But we need 1.5 ohm. It means that this is not our circuit. So let's try the fourth arrangement. Now first we will solve the series arrangement. So R dash is equal to R1 plus R2. R dash is 1 ohm plus 2 ohm. So R dash is 3 ohm. Now getting the R dash, we have to find the total resistance. So 1 by R is equal to 1 by R3 plus 1 by R dash. 1 by 3 plus 1 by 3. So 1 by R is equal to 2 by 3. So R is equal to 3 by 2, 1.5 ohm. We got the resistance for three different cases. Till here, if you face any problem, you comment me in the comment box. You can practice these questions for better understanding. Here I gave you four questions. Question 1, 2, 3 and 4. You can comment me your answer in the comment box. And if you like it, do subscribe this channel. Thank you.